Let's talk about traffic routing in Twingate and how routing works. This is especially interesting, I think, if you have more than one remote network and a lot of resources. So a resource in Twingate is a split tunnel rule, and a resource is always associated to exactly one remote network. That means that this association between a resource definition and a remote network determines what connectors are going to route the traffic to its final destination. Now, resources themselves are assigned to 0, 1, or more groups. And so it's very possible that a resource is assigned to multiple different groups, and it's certainly the case here with server.corp.int that is assigned to the IT group and the dev group, but they're all always associated to a single remote network. So server.corp.int is associated to remote network A, this IP address as well, and then those two resources at the bottom that are a little bit more broadly defined are associated to remote network B. An end user in Twingate never has to wonder what remote network to go through because that is entirely transparent from their perspective. If you take a look at an example in our environment, we have many different remote networks on multiple cloud platforms. But if I connect to my client, then in my client as an end user, I don't see any concept of remote network, I just see resources. That is because there's no ambiguity here, and every resource I try to reach is associated to a remote network, so Twingate knows exactly how to route that traffic. That's the simplest case, right? So depending on your resource definitions, you will go through either connector of a remote network associated to the resource. That's it. Now, it's not always as simple as that. There are some cases where you're going to have some level of overlap because you can define resources in a very narrow way, but also in a very broad way, and there can be overlap between resources. So you could theoretically define a resource for 10.99.3.4 and another one for 10.99.0.0/16. Technically, the single IP is part of the CIDR range that's also defined as a resource. And it's the same exact thing except for DNS here at the bottom where you have a star.domain.int and a star.app.domain.int. So you don't have to worry about any rule as long as there is no ambiguity for your users, right? So the fact that those two resources are attached to two different remote networks is not a problem as long as the two resources are not assigned to the same user. But there are some cases in which it's the case. So here, for instance, all of the members of my dev group have access to the star app.domain.int, but also the single IP and then this full CIDR range. So the way to think about routing in this case is that what takes precedence is always the narrowest resource definition. So if a member of my dev group here connects and uses, say, SSH to connect to a Linux server at 10.99.3.4, even though technically they have access to both of those rules, the narrowest of all resources that match the traffic pattern is 10.99.3.4, which means that this resource here will not create an ambiguity. This resource is the one that is going to determine routing, and routing to this IP is going to be handled by any other connectors in remote network A. Now, if another member of the same group of users decides to connect to, say, 10.99.3.5 because there is no resource for that single IP, then the narrowest resource that matches that traffic pattern on .5 happens to be the second resource here that routes through remote network B. So in this case, for 10.99.3.5, traffic will be routed through remote network B. So Remember that the narrowest definition, when there is an ambiguity, always takes precedence. In the same way here, between star app.domain.int and star.domain.int, the narrowest definition is app.domain.int, so this will tend to take precedence over the broadly defined star.domain.int. There are some cases in which you're going to have remote networks that map to maybe subnets or environments that themselves are using the exact same CIDR ranges. In this case here, in say remote network A maps to AWS and remote network B maps to GCP accounts, it's very possible that you're using the same ranges in both places. That can be a problem, right? So if you have resources and resource definitions that create ambiguity, that can be a problem if a given person belongs to groups that have access to conflicting resources. So what you can do here, it really depends on the ambiguity that you're trying to solve. If the ambiguity is on a CIDR range or a broadly defined DNS style resource, what you should do is make sure that a user belongs to only one group at a time. We have some stuff that you can use at Twingate to allow users to self-serve what group they belong to remove those ambiguities. If the ambiguity happens to be on single IP addresses or single fully qualified domain names, it's typically much easier to resolve because you can use the concept of an alias on the resource definition to remove the ambiguity. If you had, for instance, those two groups of users with access to, server1.corp.int in remote network A and server1.corp.int in remote network B, what you could do is, for both of those resources, create an alias that is going to be server1.dev.corp.int, and for this one, server1.prod.corp.int, so as to remove the ambiguity altogether. So the short version of this is that the routing in Twingate is entirely determined by what remote network your resource belongs to, by resource to group assignment, and by the fact that when there is an ambiguity, the narrowest resource definition always takes precedence. That's how you should think of routing in Twingate.